there are 5 students S1, S2, S3, S4 and S5 in a music class, and for them there are 5 seats R1, R2, R3, R4 and R5 arranged in a row. Initially the seat Ri is allotted to the student Si, where I is from 1 to 5, but on the examination day, the 5 students are randomly allotted seats. For I is equal to 1 to 4, let Pi denote the event that the students Si and Si plus 1, they do not sit adjacent to each other on the day of the examination. Then the probability of the event T1 intersection T2 intersection T3 intersection T4 is 1. So first we have to find the probability of something. The probability of an event is equal to the number of favorable ways or outcomes divided by the total number of ways possible. The total number of ways. According to the question, the 5 students, they are randomly allotted the 5 seats in the examination. So if there are 5 seats, we represent them as R1, R2, R3, R4, R5. For first seat, any one of the 5 students can be seated. So it has 5 choices. For the second seat, it has 4 choices because one student is already seated in the first seat. For R3, similarly, we have 3 choices, and for R4, we have 2, and for R5, we have 1. So the total number of ways is 5 into 4 into 3 into 2 into 1, which is 5 factorial is equal to 120. Now, we have to find the number of favorable ways, considering the condition that Ti denote the event that the student Si and Si plus 1, they do not sit together. We represent Ti as Si and Si plus 1 do not sit together. So T1 becomes S1 and S2 not sitting together. Similarly, T2 is S2 and S3 not sitting together. T3 is S3, S4 not sitting together. And T4 is similarly S4, S5 not sitting together. We have to find the probability of the event T1 intersection T2 intersection T3 intersection T4. Means we have to find a situation where S1, S2 not sitting together and S2, S3 not sitting together. Similarly, S3, S4 not sitting together and S4, S5 not sitting together. We need to find the cases where these conditions are fulfilled. For that, we take the conditions where these are satisfied. Starting with, we'll start with S1. For S1, the number of ways in which they can be seated such that the condition is satisfied is S1, then S3, then we cannot have S2 and S4. So we have to have S5 in third place, then we can have S2 because we cannot have S4, then we are left with S4, which is the fifth occupant. With S1, we also can have S4 in the second place. With S4, we cannot have S3 and S5 as its neighbor. So the choice is S2. With S2, we cannot have S3 or S1 as neighbor. We have to go with S5 and then we are left with S3. With S2 similarly, we cannot have S1 and S3 beside it. We can have S4. With S4, we cannot have S3 and S5 near it. We have to go with S1. And then when we have S1, we cannot have S2, which is already in the first place. So we can have S5 and then S3. Now, we also can have S3 and S5 in this place. This also satisfies the arrangement with all the first three positions similar, that is S2, S4 and S1 as similar. So this also satisfies the condition. Then with S2, we also can have S5 in the second place. With S5, we cannot have S4 as its neighbor. So we choose S3. With S3, we cannot have S2 and S4. S2 is also in the first place. We don't have to worry about that, but we cannot have S4. So we have to have S1 and then we can have S4. Starting with S3, we have S3 and then S1 because S3 cannot have S2 and S4 as its neighbor. So we have S3, then we have S1. With S1 we cannot have S2 and the only unique arrangement we get is by S5. With S5 we cannot have S4 as its neighbor, so we need to have S2 and then S4. With S3 again, we can have S1 and then in the third position we also can have S4 because that satisfies the condition, because S1 cannot be a neighbor to S2 but it can be a neighbor to S4. We cannot have S3 and S5. S3 is all in the first place. We need not worry about that. We cannot have S5 here. We can have S2 and then S5. All other arrangements that we make for S3 will be one of the 5 cases that we did here before. So we will not consider that. So these are the only 7 cases which are or which satisfy the condition that is given. So there are 7 conditions. If we reverse the order of this, then it also satisfies the condition. So for each arrangement, we have 2 orders. The one is as it is written and the one is the reverse order. So the total number of ways is 7 into 2 is equal to 14. The probability of the event is equal to favorable cases which are 14 divided by total number of cases which are 5 factors is equal to 14 by 120 is equal to 7 by 60, which is option C. So answer is option